1.6, other types of equations and applications. So now we're going to talk about equations with radicals. So equations with radicals, basically we're going to look at and say, well, if P and Q are two equations, and they are equal to another, or I should say expressions, and they are equal to each other, then if I take P and raise it to the power n, and Q and raise it to the power n, then all the solutions of P of this equation, P equal to Q, will be solutions to this equation, P to the n equal to Q to the n. Just saying that I can raise both sides to the same power and have an equivalent equation. Okay, so very important for us to know. Well, what does this do for us? Well, if we're dealing with equations with radicals, and I should put that up there for us. The equations with radicals, it means that we can get rid of the radicals by just raising the power of the equation. Meaning if I have the square root of x is equal to 7, then I can just square both sides. I raise the power to cancel this out, because remember, the square root of x is the same as saying x to the 1/2. So if I raise that to the second power, our power rule tells us 1/2 times 2 is 1, we just made it x, right? So that allows us to get rid of that radical. And we would end up with x is equal to 49. And that does work. If I plug in 49 for x, the square root of 49 is 7. So that works. So that's the basic idea. Now, sometimes we have equations that have just one radical in them. And sometimes we have equations that have more than one radical, or they have the radical in an interesting position. So we may have 2 minus the square root of x is equal to 7. Or we may have 2 minus the square root of x is equal to the square root of 7x, or something of the sort. So now we have different radicals there. So the process that we follow when trying to solve an equation of this sort is we're going to take advantage of this fact that we can raise them to the power. So what we do is we get a radical by itself. In this example, we have a radical, the square root of 7x. Get it by itself, and then we can raise both sides of the equation to that power. What that will do is that it will eliminate this radical. Now, obviously, if I do it here, I'm just going to show a little bit. So if I raise that and I square it, then I'm going to take this and square it. So keep in mind that it doesn't just eliminate the square root of x2. We can't just say, oh, okay, well, that's 2 squared. That's square root of x squared, so it gets rid of, and that's square root of 7x squared. No, remember this does not distribute through over a subtraction or an addition, only a multiplication or a division. But it will get rid of this, which is going to leave us with 7x over there, and over here we would have the square of a difference, so the square of the first term, 4, times 2 times the product of these two, so 2 times 2 is 4 radical x, so minus 4 radical x, and then the square of the second term, square root of x squared is x, so plus x, plus x, so we've got it to this point. Now we've gotten rid of one radical, but we still have another radical here. So we go through and we isolate that radical. So move things over to the other side. Subtract x from both sides. Subtract 4 from both sides. We have negative 4 radical x is equal to 7x minus x is 6x minus 4. So we did that. Get rid of this negative 4. Divide both sides by negative 4, and we get the square root of x is equal to 6x minus 4 over negative 4. Now we can do the same thing that we did previously. We can square both sides. We square both sides, that gets rid of the radical. We now have x is equal to 6x plus 4, minus 4, sorry, 6x minus 4 over negative 4 squared. Okay, now that we have that, we have to continue. I'm going to switch to a different color. I don't like how the blue is acting here. So we've got this, but we're still trying to get x by itself, but at least now we've got rid of the radicals. So what do we need to do? We're going to need to square this out and then solve for x. So if I come over here, we have, and I'll just put a little squiggly line here so that we can see the differentiation here. So we have x is equal to, well, 6x minus 4 squared, that's the square of the first term, 36x squared, 2 times the product of these, so the product is negative 24x, so negative 48x, and then the square of plus the square of the last term plus 16, all over negative 4 squared is positive 16. So now we have a rational equation. So I've got 16 here. I can just multiply through by 16. And I have 16x minus is equal to 36x squared minus 48x plus 16. Get it all onto the same side. So let's move that 16x over there. So subtract 16x from both sides. Then I have 36x squared minus 48 minus 16, 64. So minus 64x plus 16 is equal to 0. At this point, I could plug this directly into the quadratic formula, but I do notice that I have a common factor here that I can pull out. Well, 36 is divisible by 4. It's divisible by 9. 64 is divisible by 4, not divisible by 9. 16 is divisible by 4, so I'm just going to divide out that 4 right now to save myself some effort. So that gives me 9x squared minus 16x plus 4 is equal to 0. So with this, I could try factoring by grouping. It may work. What do I have? 9 times 4 is 36. So I need two numbers that multiply to positive 36 and add to negative 16, which means they have to be two negative numbers. So 36 and 16, 6 and 6 will give me 12, 9 and 4 will give me 36, well, so 9 and 4 will give me 13, 18 and 2, but they'd have to be, they're opposite, so that wouldn't work. So I think I'm going to have to go through and use the quadratic formula. So I'm just kind of thinking through which ones will work. So quadratic formula, x is equal to negative 16 plus or minus the square root of negative 16 squared minus 4 times a, which is 9, times 4, which is c, over 2 times a, so 2 times 9. Never said it would be quick and easy. And this will, remember, this was just some random problem that I happened to write on the board and say, hey, what happens if this? But you see that by taking the steps, we can work through it. So we get negative 16 is 16 plus or minus the square root of 256 minus, we got 36 times 4 is 136, right? 30 times 4 is 120. Okay, it was 36 times 4, so 6 times 4 to give me 24, so 144. 2 times 9 is 18. So we got to that point. So 256 minus 144 gives you, what, 112? So 16 plus or minus the square root of 112 over 18. Let's see, is 112 divisible by, 112 is divisible by 4, right? 25 times 4 is 100. 3 times 4 is 12, so 28 times 4. So we can simplify it a little bit and say that's equal to 16 plus or minus 2 radical 28 over 18, which allows me to simplify it some more and say, okay, now I can divide everything by 2. So we're going to come over to this last little spot over here. Sorry, this took up so much space on the board. But we're going to have 8 plus or minus the square root of 28 over 9. So 8 plus or minus the square root of 28 over 9. 28, well, that's 7 times 4. Can we pull another one out? We can, but it's not going to help us with the denominator. So we can pull that out a little bit more. X is equal to 8 plus or minus 2 radical 7 over 9. Not pretty, but doable. It did work. If I hadn't started so huge here, I wouldn't have had to do so much there. And if I actually pulled something that worked nicely, then it would have come out easier. But this was just grabbing some random equation, putting in there, and it did work. And it showed that we could work on both sides, isolate the one radical, isolate the other radical, and work from there. Well, if you don't like this one, let's go to a different one. If you do like this one, we're still going to go to a different one. Because let's face it, you're watching a video. So you have no power over what happens. Non-interactive. You just have the power to fast forward through it, put it at a faster speed or a slower speed, turn it off. But no choice over what I decide to do while I'm doing the video. Okay, so let's look at an example, another example here. X minus the square root of 4x plus 12 is equal to 0. Okay, so if we want to do this, we need to isolate the radical. So in this case, I see that this is positive and this is minus, negative. That's a 0 there, so I'm just going to move the radical over to the other side and say x is equal to the square root of 4x plus 12. Now we see that we can square both sides. And if we do so, then we're going to have x squared is equal to 4x plus 12. Now we see that we can move everything over to the same side. X squared minus 4x minus 12 is equal to 0. And as we do that, now we say, what are two numbers that multiply to negative 12 and add to negative 4? The signs have to be different. That's why it's negative 12. The larger one has to be negative. So I would look at that and say negative 6 and positive 2. So x minus 6 and x plus 2. is equal to 0. So x is equal to 6, and x is equal to negative 2. So we came out with these possibilities. So just like when we were dealing with rational equations, remember that we have changed this equation. We started with this and moved it to this. By doing that, we guaranteed that any solutions to this first one will be in here. But it's possible by raising this power and getting rid of that radical that we may have added in other solutions that do not work for the original equation. So let's take a look and see. Well, let's plug in 6 and see what happens. So if I set x equal to 6, then I have 6 minus the square root of 4 times 6 plus 12 equal to 0. 6 minus the square root of 4 times 6 is 24. 24 plus 12 equal to 0. 6 minus the square root of 24 plus 12 is 36. 36 equal to 0. 6 minus the square root of 36 is 6 equal to 0. And that's correct. 0 equal to 0. So that one tests out. We like that one. X equal to 6. Let's check out x equal to negative 2. So if x is equal to negative 2, we have negative 2 minus the square root of 4 times negative 2 plus 12 equal to 0. Negative 2 minus the square root of negative 8 plus 12 equal to 0. Negative 2 minus the square root of negative 8 plus 12 gives you positive 4 is equal to 0. So negative 2 minus the square root of 4 is 2 equal to 0. We get minus 2 is negative 4 equal to 0. Not in any math that I'm familiar with. So we find that x equal to negative 2 is not a solution for this radical equation. But x equal to 6 is. So that is perfectly valid and we can use that. So just remember, anytime you change the equation in this, like raising a power or getting rid of denominators, we have to look back at the original equation. When dealing with the rational equations, we had to make sure it didn't violate the rule that we can't have a 0 in the denominator. When dealing with these, we just have to make sure that it really is a possible solution, because obviously the square root or the radical makes things work a little bit differently, and when we eliminate it, we open up other possibilities that may not have existed before. So let's get rid of this. Now let's try this one. I'm going to get rid of that marker. That's it, hitting the garbage. The cubed root of 5x squared minus 12x plus 6 minus the cubed root of x is equal to 0. So we have the cubed root here, cubed root here. So remember, what we want to do is we want to isolate one of those radicals. Remember, we can't just take just cube both sides and call it good, because we've got this subtraction in between here. So we need to isolate a radical and then eliminate it that way. So I see this one's positive, this one's negative, so I'm just going to move that one over to the other side, and I end up with the cubed root of 5x squared minus 12x plus 6 is equal to the cubed root of x. Well, that actually worked out kind of handy, because Now when we cube both sides, to get rid of that radical, it actually gets rid of both radicals. So we end up with 5x squared minus 12x plus 6 is equal to x. Move the x over to this side. 5x squared minus, or it's plus x here, so we're going to subtract it, so minus 13x plus 6 is equal to 0. We're now in a quadratic. We can use the quadratic formula. So x is equal to negative 13 plus or minus the square root of negative 13 squared minus 4 times 5 times 6 all over 2 times 5. So now we can start working through it. X is equal to 13 plus or minus the square root of 169 minus 120. Oops, 120 over 10, which is nice because 169 minus 120 is 49. So x is equal to 13 plus or minus the square root of 49 over 10, which is equal to 13 plus or minus 7 over 10. So continuing on with that, we just 13 plus 7 is 20, divided by 10 is 2. So x equal to 2. And 13 minus 7 is 6, divided by 10, so 6/10 or 3/5. Well, now, just as we did with the previous one, we need to look at this and make sure that they work under this situation. So let's start with 2 because that looks easier to me. So if x is equal to 2, then we have the cubed root of 5 times 4, 2 squared is 4, minus 12 times 2 plus 6, minus the cubed root of 2 is equal to 0. The cubed root of 20, so we have 12 times, that's a plus 6, hard to see that plus 6, there we go. 20 minus 24 plus 6 minus the cubed root of 2 is equal to 0. 20 minus 24 is negative 4 plus 2 is, plus 6 is 2. So we have the cubed root of 2 minus the cubed root of 2 is equal to 0. Yeah, taking something and subtract it by itself, it sure is. So we like 2. The question is, do we like 3/5? And 3/5 looks like it's going to be just a little bit more work. So I went out of frame there. Okay, so let's look at that one. So the cubed root of 5 times 3/5 squared is 9/25 times 9/25 minus 12 times 3/5 plus 6 minus the cubed root of 3/5 equal to 0. Boy, I sure hope this comes out to be 3/5 so I don't have to do a lot of hard work. So we have the cubed root of, well, 5 divided by 25, so we get 5 in the numerator, in the denominator, so we have 9/5. Make that look like a 5. So 9/5 minus, that was 12 times 3/5. Let's put parentheses there so it shows up better. So that's 36/5 minus 36/5 plus 6. Well, if I want to put 6 over 5, that's 30 fifths. So 30 fifths minus the cubed root of 3 fifths equal to 0. So 9 minus 36 gives you negative 27, right? So negative 27 plus 30 gives you positive 3. So we have the cubed root of 3 fifths minus the cubed root of 3 fifths is equal to 0, and yes, it is. So yes, that one worked too. So x equal to 2 and x equal to 3 fifths are the solutions to this equation with radicals. So just to show that we can take it up to other powers. Sometimes you may even have it where you have a radical, a cubed root and a squared root, or a fourth root and a squared root. And you just work with them as they come. In this case, they canceled out nicely, but other times you're just going to have to take it a piece at a time, work through it, and deal with your equation of radicals. And if you're patient and you just take it a step at a time, you can get it through it. Don't forget, in the end, whatever you come up with your solutions, you do have to go back in and make sure that they actually work. This isn't just the check that we used to have to do if you solved a problem and then you throw it back in just to make sure you got the right solution. This is because by raising the powers, we actually may be creating additional solutions. So we need to make sure that we didn't add any extra solutions by raising the power. So you've got to go back and check and make sure that they all work. And there we go, equations with radicals.